Our journey did not commence in a state-of-the-art laboratory, but rather through a keen observation of the challenges facing our local community. We were driven by a fundamental question: how can scientific principles be leveraged to enhance the quality of life in our hometown? This inquiry served as the catalyst for our rigorous research and development. The path toward discovery was paved with technical constraints and recurring empirical setbacks. We encountered numerous instances where our result deviates from the initial hypothesis. However, we view these discrepancies not as failure, but as vital data points. Through an iterative process of trial and error, we learned that scientific progress demands both analytical rigor and the resilience to pursue excellence despite initial shortcomings. When we were afforded the opportunity to present our findings on the global stage, our primary sense of pride stemmed not from the accolades but from the validation of our methodology. We demonstrated that localized problems, when addressed with global perspective, can yield innovations of international significance. We remain steadfast in our belief that science knows no boundaries. It is our conviction that systematic inquiry, fueled by unwavering dedication, is the ultimate key to transforming classroom knowledge into sustainable societal impact. Let us explore the tangible impact our project has made toward a more sustainable global future. Imagine a world where the air is clean, where waste become resource, and where nature inspires innovation that save lives.
Good morning, honorable judges. My name is Chayapon Prathama.
And my name is Supachok Tamendikun. We are proudly presenting Thailand's innovation. Today, we present to you the ecosystem foam, a sophisticated biofoam innovation derived from reclaimed silt for the advanced capture of carbon dioxide and fine particulate matter in the air.
Today, air pollution is one of the world's deadliest environmental crises. More than 7 million people die prematurely every year due to polluted air. Carbon dioxide is warming up our planet. Those tiny PM 2.5 particles are entering our lungs, bloodstream, even our brains. At the same time, in Thailand and across the world, tons of silk waste from silkworm farm are discarded. This natural protein fiber is biodegradable and rich in property, but never burned or thrown away. So we asked what if silk waste could help clean the air?
And that's where the ecosystem foam was born. We take these calcium fibers and transform them into a lightweight and porous biofoam, capable of trapping PM 2.5 and absorbing carbon dioxide. Our process uses green chemistry, minimal energy, no toxic additives, and follows a circular economy principle. The ecosystem foam can be used in many places and products, such as filter sheets on windows, home, school, a discardable fire-fighting air filter, wall panels in factories and urban spaces, and even a wearable technology in the future. Well, what makes it so innovative? It turns an agricultural waste into an environmental technology. It is biodegradable, affordable, effective. It helps empower the local community to help clean the air naturally. The experimental method, Phase 1, Bioextraction. We began with the calcium fibers often treated as waste. Instead of letting them end up in landfill, we apply a gentle bioextraction process. By using a mild alkaline solution under controlled conditions, we successfully isolated the serine protein, the hidden gem of silk waste, and this is the base of our material. Phase 2, the synthesis of ecosystem foam. We moved the synthesis of a star material. We took the extract resin solution and blended it with a highly effective carbon capturing agent. The magic happens when we introduce gas and foaming agent to the solution. This creates a highly porous and stable structure. The resulting structure is not just random. It is a precisely engineered bioscaffold designed to maximize surface area, creating countless tiny traps for PM 2.5 particles. Then, we cure the foam using a low-temperature drying process to make sure that the structure is locked in and make it ready for testing. Phase 3, the carbon capture validation. We put the ecosystem foam to the ultimate test and build a custom sea chamber to simulate a controlled environment. Here's how it works. We place a sample of our ecosystem foam inside the chamber and introduce them into a known concentration of carbon dioxide gas. Then, using a highly accurate infrared gas sensor to monitor the carbon dioxide concentration level in real time. Then we compare the results against each other to furthermore validate our findings.
The result. Following the testing of EcoSeal foam, we observe a significant reduction in carbon dioxide concentration by the initial concentration of 1000 ppm decreased to 650 ppm within 2 hours, representing a 35% reduction. In contrast, a control chamber without EcoSeal foam shows negligible change. Our foam exhibit high porosity and low density. This porous and lightweight structure provide a large surface area for carbon dioxide absorption. Moreover, the foam maintains structural integrity over 7 days under ambient conditions, demonstrating durability and suitable for practical application. Regarding environmental sustainability, the EcoSeal foam is fully biodegradable. Samples buried in natural soil show 15% degradation within 30 days and complete degradation within 90 days. That indicate the EcoSeal foam is not only effective for carbon capture but also environmentally friendly and sustainability. In summary, EcoSeal foam can reduce carbon dioxide concentration by up to 35% within 2 hours. It possesses highly porous and stable structure suitable for practical use. It is biodegradable, ensuring environmental sustainability. The finding validate the EcoSeal foam as an effective and sustainable bio-innovation for global carbon mitigation. Next, we expect EcoSeal foam to first, reduce air pollution in city and rural area. Second, improve public health and respiratory well-being. And the last, promote biocircular green or BCG and inspire young innovators to explore natural material for modern problems. With further developments, EcoSeal foam can be deployed at scale to make clean air accessible, not just to a few, but to all. EcoSeal foam is more than just a product. It's a mindset shift from waste to worth, from passive pollution to active purification, from what we throw away to what saves our future. We believe the most powerful innovations are not synthetic. They're inspired by nature, tradition, and local wisdom.
So, I will leave you with this question. What if the answer to climate change and air pollution has been hiding inside of these silver cocoons all along? Thank you.